This example deals with metric conversions dealing with three-dimensional objects. So just like in our last example, we're going to deal with the conversion first and forget about the fact that it's three-dimensional, and then we'll add in that third dimension. So in this first case, we're going to convert 26 meters cubed to millimeters cubed. So locate meters on your number line, and we're going to move it 1, 2, 3 spaces to the right to convert to millimeters. That's the same as multiplying by 10 cubed. Now let's add in that three-dimensional shape here. What I need to do is I need to raise my conversion factor to the dimension that I'm working in. In this case, it's 3 dimensions, or it's the same exponent that my units have on them. So this changes my 26 times 10 to the 3 to 26 times 10 to the 9th. So I just had to multiply those 3's together. Now, when you write this out, it's a really long number. I'm at 26 trillion, or 26 followed by 9 zeros, if I can get them in there, millimeters cubed. So if you put that in scientific notation, that means to put one significant digit followed by a decimal, then any other digits that you have that aren't a 0, multiply by 10, and the exponent should reflect how many spaces you had to move that decimal in order to get the 2.6. So in this case, I would have had to move the decimal 3, 6, 7. So I'm at 10 spaces to the left. So that would be negative 10 millimeters cubed. In part B, we're going to convert a number that's already in scientific notation. So it's a 9.8 4 times 10 to the negative 6 kilometers cubed, and we're going to convert that to centimeters cubed. So when I find kilometers on my number line, I've got to move 1, 2, 3, 4, 5 spaces to the right to convert it to centimeters cubed. So that's going to be multiplied by 10 to the 5th power. And I'm just going to leave it in scientific notation like that. And then remember, I have to multiply the conversion factor by the dimension I'm in. So that means that 10 to the 5th needs to be raised to the 3rd power. So that's actually going to make it 10 to the 15th. Now I did it like this because, 10 to the negative 6th, because I can combine my 10 with the exponents here and just leave the 9.84, and I can answer directly in scientific notation. So 9.84 multiplied by, when I'm multiplying powers with the same base, I just write the base once, add the exponents together, which is 9. And I'm done. That's actually my answer in scientific notation. 9.84 times 10 to the 9th centimeters cubed. Pardon me, that's cubed, not squared. And if you want to answer in standard notation, you just multiply that out or move that decimal 9 spaces to the right. So it looks like this. 0, 0, 0, 0, 0, 0 centimeters cubed. Now, in that very last example, we're going to convert 389,200 centimeters cubed to micrometers. So when you find that on your number line, it's 1, 2, 3, 4 spaces to the right, or really multiplied by 10 to the 4th. The next thing we need to do is add in that dimension of 3. So I'm going to raise my conversion factor to a power of 3. So 389,200 times 10 to the 12th, that's 4 times 3. Now, when you write it out in standard notation or standard form, it's a very large number, 398,200 with 12 zeros behind it. So you can write that out, or maybe just leave it in scientific notation like I'm going to do. 3.892 times 10 to the negative 17th micrometers cubed.